So today we're going to look at a couple different applications of proportions that we've been looking at, and we're going to kind of tie them to percents. So up here, it says in a percent proportion, one ratio compares a part of a quantity to the whole quantity. The other shows the equivalent percent written as a fraction over 100. So we know that percentages are just fractions written over 100. So depending on the wording of the problem, you may find the following two formulas beneficial to set up your proportion. So one way that we can look at this is, remember we talked about kind of making a little key when we make a proportion? If I'm seeing the words is and of in a problem, the proportion that I can set up is that is over of equals the percentage they give me over 100. I can also think of it as, and I think this might be a little bit easier, but it all depends on how you're thinking. If I think of part over whole, whatever portion they give me over what the whole of that portion is, and then setting that equal to the percentage over the whole, which in this case with percentages is a proportion. So what I mean by that, let's look down on a couple of these and then we'll do a couple as practice. If I look at like number 1, they're asking me 18 is what percent of 40. So that would kind of be, if you think of it in terms of that first formula that we looked at, my is 18, my of is 40. And they're asking me what is the percent. So the thing they're asking me about is where my x is going to be, and then my denominator is going to be 100. So it seems like we're pretty good at solving proportions. So remember, I'm going to cross multiply. So I'm going to say 40x equals 1800. And then I'm going to divide by 40. And then x equals 45. We'll go back and do a couple more of these as practice, but let's move on down here. If I look at like number 5, they kind of switched up what they want me to do. They're saying 28 is 4% of what number? So notice the of, they didn't give me. That's what they want me to find. So if I'm setting up that proportion, I'm saying 28 over x equals, and then they gave me the percent part, 4 over 100. So again, my math doesn't change. I'm going to cross multiply, and that's going to give me 2800 equals 4x, divide by 4, so x equals 700. Now let's do one more like this, where we're going to kind of look at a little bit more application, more of a word problem. So let's look at number 15. Bethany uses 8% of her weekly paycheck to pay for gas. If she spent $34.12 on gas this week, how much was her paycheck? So if they're giving me a percentage, that's kind of a giveaway that that's going to be one side of your proportion. They're already giving that to me. Now they're saying she spent $34.12 on gas this week. How much was her paycheck? So again, I'm going to think back to like up here, each of these things, and you can think of it in either of those ways. So parts, the whole is what her whole paycheck was, and that goes in the bottom, in that denominator. And then my numerator is going to be how much of it she spent. So then don't let the decimal scare you. Your math is staying exactly the same. You're going to do your cross multiplication. So that's going to give me 3,412 equals 8x. And then I'm going to divide by 8. And then x is going to equal $426.50. And we'll do the rest of those other ones together in class. So let's move on. Now we're going to look at something called percent equation. So instead of setting up a whole proportion, sometimes it's easier to find percentages of a full number, or basically solve those last problems we did by setting up a little equation. But instead of using proportions, we're going to be using decimals. So like it says here, the percent equation is a quick way to find a part of a whole quantity by multiplying the whole, so whatever you want to find a percentage of, by the percent written as a decimal. So if we fill in this equation, part equals whole times percent. So if I'm looking at, sorry, I'll give you a second to copy that down, or you can pause the video whenever. If I look at these down here, the only tricky part of this is you need to remember how to change those percentages into decimals. And some of these you guys are pretty good at. Some of them are a little bit trickier. But so if I'm trying to find, like number one, 5/12% of 90. So my part is what I'm looking for. I'm looking for what that part is. So that's going to be my x here. And then 12% of 90. Well, if I follow my equation up here, my whole is 90. I'm just going to put this in parentheses to show that we're multiplying. And then you got to remember how I do that math. How do I turn 12% into a decimal? Now, most of you are good with, I just got to move that decimal place over 2 places to the left. And then you're just plugging that into your calculator. 90 times 0.12 is 10.8. Now, we could have found that with a proportion, but this is sometimes a little bit quicker. So let's skip down to, because pretty much all of those go the same way. Let's skip down to these ones down here. So it says number 7, Kate spent 23% of her last paycheck on groceries. If she made $908, how much should she spend on groceries? So it might be helpful if I'm looking at that equation to kind of color code that. So remember, part equals whole times percent. So my percent, I'll make that green, they gave me is 23%. She spent 23 of her last paycheck on groceries. If she made $908, how much did she spend on the groceries? The other part they gave me was the whole. They gave me her whole paycheck. They want a part of what that paycheck was. So the thing that I'm looking for, again here, is the part, x equals, the whole they told me is 908. And now I got to convert that percentage into a decimal, which if I move that decimal place over 2 places, it's going to be 0.23. And when I do that math out, $208.84 is how much she spent on those groceries. So let's take a look at one more. Let's take a look at 9, because that one's a little trickier. So there were 80 golfers in the first round of the tournament. Of the 80, 62.5% qualified for the next round. How many did not qualify? So this is actually, it's very similar to the last one, but I'm going to, again, kind of color code this. So they are giving me, let's do our percent first. They're giving me a percent that they want me to find. 62% of all those golfers. And then my whole, the total number of golfers was 80. So once again, I'm going to say x equals whole, 80, times my percent, which in this case is 0.625. And then if I do that math out, there were 40 golfers. Now, the thing that makes this one a little bit tricky is you have to think about what this actually represents. They're saying that 62.5% qualified for the next round. The question is asking how many did not qualify. So if there's 80 total golfers and 50 of them qualified, my last step in this problem to actually answer the question is say, okay, take the total number, take away the people that did qualify, and you're going to be left with who did. Okay, again, we'll do more of these in class, but now let's do this last piece. If we go to discount and markup, this is really where this stuff becomes a little bit more applicable in real life. Because if you're out shopping or something, a lot of times you'll see something's discounted or marked up by a certain percentage. Most times it's not a dollar amount. So we're going to see how we can actually use this to figure that sort of stuff out. So first thing, discounts are subtracted from my original price, whereas markups are added. And then that last piece, you'll see in all these questions, it's asking you what the actual selling price of all this stuff is. That's what we're going to put in that last blank. The selling price, or the sale price, the amount you actually end up paying, is the amount, like it says there, amount the customers end up paying. Some examples they've got here for us. So I've got a pair of jeans, they're $58, and they are 58% off. So I'm going to use that same equation that we used on the last page. So my part is my X. That's how much I'm looking for the discount. So that X is going to be the discount. And then I'm going to take my whole, which is $58, my full price, and I'm going to multiply it by what the discount is. And if I do that, I'm going to come up with $8.70. But remember, that's just what the discount is. When I'm actually looking for what the sale price is, we're kind of solving this like we did that golfer problem on the last page. I'm going to say, okay, my initial sale price was $58, but then they're taking 15% off, which we figured out is $8.70. So when I do that math out, my actual selling price is $49.30. Now let's do a markup problem. So if we'll look at number 5. They've got a wedding dress. And granted, some of this stuff, markups aren't as common as discounts, but some of this stuff, like a wedding dress or a sofa, stuff that people are trying to sell, that there's demand for, the price might go up from what it normally was. But that doesn't really change what I'm doing here. I still need to do my math to find out what that markup actually means in terms of dollars. So I'm going to say my part equals my whole, which I'll put in parentheses, times 0.03, which is what that markup is, as a decimal. So if I do that, I'm going to find that in dollars, in relation to that dress, is actually $18.75. So your math hasn't changed there. The only thing that's changing is when I'm figuring out the selling price. If I'm marking something up, I'm adding to its cost. So I'm going to take $6.25 and I'm going to add $18.75 to it, which makes my final selling price in this case $643.75. So that hasn't really changed much. Now, when we're talking about down here at the bottom, there's one little piece that we need to add. And again, this is a little bit more real world use of these percentages and proportions and all this stuff. Most stuff that you buy is going to have sales tax on it. So sales tax is a percentage that is, of course, added to selling price, as is a tip. So if you're somewhere, if you're getting dinner or something, it is typical that you're going to add a little bit of a tip onto your bill for the waiter. But this pretty much works the same way. So let's turn to this page. So like number 9, they're asking me to find the final price of an $849.99 laptop with a 6% sales tax. The actual math that I'm doing here is very similar to this discount and markup. If I'm adding, all of these are pretty much like a markup. So you can think of that. I actually want to put that on our notes back here. Think of like a markup, because it's just more money that's being added to what you're actually going to pay in the end. So if I'm looking at number 9, once again, I'll find what the sales tax is, like I do with finding what a markup is. I'm going to take my price and I'm going to multiply it by how much it's being marked up by, which in this case is the tax, which here is $51. And then I got to go back and take my original and add that 51 to it. So my final price is going to be $900.99. And much like the rest of them, we'll do a bunch of these other ones in class.